This is Y Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today, I am going to explain you the concept of problem solving on indexing and hashing mechanism in DBMS. Indexing and hashing in DBMS. So, indexing. So, what is meant by index and how we can perform index and what is the uses of indexing mechanism in the DBMS. So, here the indexing mechanism is used to speed up access to desired data. So it is a mechanism which is used to speed up your accessing the data, So in the database, there are different types of data, but the users are requested to retrieve particular data on time basis. So at that moment, there is a mechanism called indexing, which is used to access your data very fastly. So this indexing mechanism is mainly for speed up accessing your data. So example, author cataloging library. So in the library, in real time, the library, there is a self-contained different types of books, and each and every book is related to the department. So by maintaining the department wise books, the department students can access data books easily. So that is the mechanism of usage. To do that indexing mechanism, what is the main key for searching process? So here the search key is one main attribute. So the search key is a main attribute to set of attributes used to look up records in a file. So the search key is used to look up the records in a file. So each and every file, the database contains different types of nodes. That nodes are nothing but what? Areas. And these nodes contains what? Files. And these files contains what? Records. So to search the record of the data, we can use indexing mechanism. But for this indexing mechanism, we can use an attribute called search key. So which is the attribute to look up the records in a file. And to all these, a index file also maintained. So an index file consists of records called index entries of the form. So all the records will be having a separate index file. So in that index file, the index search key is looking all the records. And index files are typically much smaller than the original file. So index files are typically much smaller than the original file. So there are two types of basic kinds of indexes or indices. So one is ordered indexes and the second one is hash indices. So one is ordered indices and hash indices. So ordered indices are nothing but what? The indexes which are maintained, the search keys are stored in sorted order. So search keys are stored in order. That means 1, 2, 3. They are maintained in a particular sorted order. But in the hash indexes, search keys are distributed uniformly across buckets. So each and every index maintains search keys. That search key is assigned to each bucket. Using hash function. But in the ordered indices, what? The index file contains search keys. That search keys are stored in ordered wise, that is ascending order. But in the hash indices, that each and every search key is associated with each bucket, so that it maintains hash function also. So those are the two kinds of indices are available to speed up the accessing mechanism of the data. and what matrices based the index performs actually. So how we can evaluate the index? So index evaluation metrics we can call it as. So access types are supported efficiently. Access types are supported efficiently. Records with a specified value in the attribute or records with an attribute value falling in a specified range of values. So for specified range of values like 201 to 210, one key is there, or else for each and every one we can have a search key, separate key. So what is the metrics actually to speed up the indexing mechanism? What is the process? What are the metrics that we are going to use for indexing mechanism? So to reduce the access time, so it takes less amount of time to access the data. Reduce the insertion time also. So to insert the values into the particular file, inserting the values for the particular record, it takes less amount of time. And to delete the value also, to delete the value or to delete the table value also, it takes less amount of time. And also space overhead. So unnecessary elements, unnecessary values are not able to insert it. So to do that indexing mechanism also use it. So these are the metrics to speed up the accessing time and to speed up the insertion time, to speed up the deletion time, and to reduce the space overhead on the table, the database. We have to use this indexing mechanism. So ordered indices, we already said that what ordered indices and hash indices. So in unordered indices and ordered index, the entries are stored and sorted on the search key value. So on basis of search key values, the index entries are stored. On basis of search key value, the index entries are stored. So if search key values are found first, then the value in the index entries will be stored as first. If the search key value is founded as last, then the value stored in last in the index entries. So example, author catalog in library. The next, primary index. So primary index is nothing but what? In a sequentially ordered file, the index whose search key specifies the sequential order of the file. The search key which specifies an order of the file, that is nothing but what? A primary index, sequential order of the file. It specifies sequential order of the file. So that is nothing but what? Primary index. Also called as what? Clustering index, to avoid confusion with the primary keys. The search key of a primary index is usually but not necessarily the primary key. So the search key of a primary index is usually but not necessarily the primary key. While in the secondary index, an index whose search key specifies an order different from the sequential order of the file. So it specifies an order, it is different from the sequential order of the file, and also called as what? Non-clustering index. Index sequential file. So ordered sequential file with primary index. The file which is having the order sequential file with primary index is called as what? Index sequential file. So dense index files. That is nothing but what? Index record appears for every search key value in the file. So take an example as a file. This is all about to file. So in this example, an index on ID attribute of instructor relation. So this is all about the file which contains an instructor table. So this table or relation, this is instructor table or relation, which contains what? Which contains ID, instructor name, instructor course, and instructor salary. instructor salary. So for this all, the instructor IDs, instructor name, instructor course, instructor salary, the primary key attribute is what? Instructor ID. So on the basis of instructor ID, remaining all the values are going to be retrieved. All the values are going to be retrieved. For this, to do this, we have to implement the indexing mechanism. We have to implement the indexing mechanism. This is called as what? Indexing. And all the entries in this index is called as what? Index entries. So index entries. In that index entries, all the entries are nothing but what? Primary attributes. So all the index entries, index entries in the index is called as what? Is called as primary key attributes. It's called as what? Primary key attribute. So here the first primary key indicates that what? The record specifies what record it pointed and what record it specifies. And second record is also specifying the second value and it pointers. So from here, whenever the first index entry search key value is pointed to the first one, it is automatically pointed to the next level, and it is also automatically pointed to the next level, also automatically pointed to the next level. Like that, it searches for all the entries which are available in the file up to last entry, So here the dense index on department name. So we can take it as a not only ID, we can take it as a department name with the instructor file sorted on department name. So here we are taking the index entry as a department name. So these are called as what? Index entries. These are called as index entries because all the entries are stored in index. So index entries. So index entry name is what? Here the department name. So department name can be taken as a instructor index entry, and with these index entries, with these search keys, all the values to be pointed, and it is pointed to the next value, and that value is pointed to the next value, and that value is pointed to the next value. Like that, it pointed towards last entry of the file. Last entry of the file. So up to that, it finds each and every index entry. There is nothing but search key. Searches for each and every records, and until it finds in the last stage. Of the file. The next, sparse index files. So it contains index records for only some search key values. So sparse index contains index records for only some search key values. It applicable when records are sequentially ordered on search key. To locate a record with search key value k. So to locate a record with search key value k, we find index record with the largest search key value less than k. So we need to find that index. Record with the largest search key value less than k. So k is nothing but what? Search key, which contains the largest search key values less than k. So search file sequentially starting at the record to which the index record points. So here the search key, and this is the index record. This index record points to the next index record, and this one pointed to the next index record. So here these are all sparse index entries. Because it takes only some search key values as an entries. As an index entries. So only some search key values they are taken as a index entries. So to locate that record with search key value k, we are finding each and every record, and it should be pointed to the next value of the record. next value of the record. So like that, it is pointed to the next value, and the next value till last value it is pointed. Last value it is pointed. So these are all index record points which are pointed to the next level of index records. So compared to the dense indexes, versus sparse indexes. So it takes less space and less maintenance overhead for insertion and deletion operations. So compared to dense indices, sparse indices are taking less space and less maintenance overhead for insertion as well as deletions operations, and generally slower than dense index for locating records. So sparse indexes are somewhat slower than dense index file for locating records. That is nothing but to find out the record. And for this good trade-off, the sparse index with an index entry for every block in a file, corresponding to least search key value in the block. So the sparse index with an index entry for every block in a file corresponding to the least search key value in the block. So here this is taken as an example which contains data block, data block 0 and data block 1, and this is all about index entries, So this index entry, that is nothing but search key value. The search key value in this block will be corresponding to at least one data block. So this is one data block, contains what? The table ID, name, course and salary. And similarly, the data block 1 also having the same search key values with the IDs, names and codes and salaries. So like the way you can understand that compared both sparse indexes and dense indexes, because of that maintaining less amount of space that is taken overhead by the indexes, it takes only in good trade-off. Secondary indices. So here, instead of creating primary indexes, we can also create one more indexing mechanism called as what? Secondary indices. So instead of using primaries, we can also use secondary. Indexing mechanism to access very fastly. So here, this is all about data block. That is nothing but a file. That is nothing but records all. So for this all, the index entries are all what? Salaries here. For all these salaries are primary indexes. All these salaries are primary indexes or primary index entries. And for this, from these, the secondary indexes also maintained. Secondary indexes are maintained, and these indexes are look up into the records of the file. These secondary indexes are look up into the records of the file. So after look up into the record from this primary index, it finds and it is pointed to the next value of the record. So like the way the primary indexes are pointed to the secondary indexes, and the secondary index takes that values from the primary index, and it lookups with the data. It lookups in the data block whether the particular values are stored or not, and particular values have to be retrieved or not. So here, index record points to a bucket that contains pointers to all the actual records with that particular search key value. And the secondary indices have to be dense. Indices. So all the secondary indices are to be in dense indices. So that is all about secondary indices and primary indices. So once again we revise the topic which we discussed in this session. So here what we discussed in this session, we have what is meant by indexing, what is meant by hashing, and what are the values are measured for the indexing mechanism. So here we can have that indexing mechanism which is used for speed up access the data, which is used to speed up your accessing the data, and a search key value is also there. So in index, the file consists of all the index entries. The index contains what? All the entries of the file. So each and every entry in the index file, each and every entry in the index file will be called as what? Search key. Will be called as what? Search key. Search key in the index entry of index file which pointed to the data blocks. So here there are two types of indices are there. One is what? Ordered indices, and the second one is what? Hash indices. One is what? Ordered indices, and the second one is what? Hash indices. So ordered indices are nothing but the search keys are stored in sorted order. Search keys are stored in sorted order. So search keys are always stored in sorting order, like 1, 2, 3, 4, 5, like this. All the search key values are stored in sorted order. But in the hash indices, search keys are distributed uniformly across buckets using hash function. So in hash indices, the search keys are distributed. Each and every search key is associated with one bucket. Each and every search key is associated with one bucket with the help of hash function. So for this hash function, we are creating some buckets, and the search keys are distributed uniformly across that buckets. So on what metrics based we are going to implement this indexing mechanism means we need to improve the access time. That is, we need to retrieve the records with the less amount of time. That means you need to reduce the access time. So based on the accessing methods, we are going to reduce the accessing. And the second one is insertion time. So take less amount of time to insert the values, and take less amount of time to delete the values also. And also reduce the space taken by the index entries or having the bucket size also. Reduce the space overhead. Also, so to do this, to achieve this all, to reducing the access time, to reducing the insertion time, reducing the deletion time, reducing the space overhead taken by the indexes will be reduced. So these are all the metrics that are implemented for indexing mechanisms. And what are the ordered indices? So ordered indices, there are different types of ordered indices: primary indexes, secondary indexes. So ordered index entries are stored on search key values. So primary index is nothing but what? In a sequential order file, the index whose search key specifies sequential order of the file. So that is nothing but primary index. The first sequential order of the file indicates that what? Primary index. The secondary index whose search key specifies an order different from the sequential order of the file is called as what? Non-clustered index or secondary index. So which is different from the first primary index. And the index sequential file, the ordered sequential file with primary index. Called as what? Index sequential file. So here the dense index files. So index records appears for every search key value in the file. So index record appears for every search key value in the file. So this is all about file or data block. We can take it as a file or data block. So instructor table or instructor data block. which contains index instructor ID, instructor name, instructor course, instructor salary. So all these are the name and the course and the salary are non-prime attributes. Non-prime attributes. And here the index on ID, this is nothing but what? Index, and we can call it as what? Index entry, because the entry inside of the index. So we can call it as what? Index entry. And this index on ID attribute of instructor relation. So this is nothing but what? Index entry or index entry or index. So which is pointed to the file, which is look up into the file, and if it founds it, the file pointed to the next record, and the next record up to last record of your file, up to last record of your file, it points up to last record of your file, it points. So all this name, course, salary are always depending upon this search key value. So here the ID is the search key value, ID is the search key value, and remaining all others are only for the records, only for the records to be retrieved, only for the records to be retrieved. And this dense indexes we can also take as a other non-prime attributes also taken as an index entries. So here I am taking department name as an index entry. I am taking department name as an index entry. So here the index entry is what? Department name. So that means this department name index entry is pointed to the search key value, that is ID, index ID, and from this all other names, instructor course, instructor salaries. So instructor name, instructor course and instructor salary are depending upon this index ID, but this index ID is pointed from index search key value, what? Department name. So here department name will be taken as a search key value for retrieving all this name and course and salary. And sparse index files which contains index records for only some search key values, and it is also available in sequential order of the search key values. So here for some of the search key values we are taken some of the search key values only. So here this one is one search key, this one is one, this one is one, only some certain search key values. With that search key values we are going to search the records, we are going to look up the records in a file. So this will be pointed to the next record, this will be pointed to the next record, up to the record which we are going to search is to be found, the record which is going to be searched for found. So here compared to sparse to dense indexes, so comparing with both two, it takes less amount of space and less maintenance overheaded for insertion and deletion operations. And a sparse index with the index entry for every block in a file corresponding to least search key value in the block. So this is called as what? Data block which maintains all attributes, of table, and this will be the index, and which contains index entries. Index entries are always set that what? Search key values. So these search key values are pointed to the file to look up the records, and other indexes entries are also pointed to the data buckets or data blocks to look up the records in a file. So that is data blocks, and search key values are associated with here. And secondary indexes are, it is one type of mechanism which is used as a primary indexing, but instead of using primary index we can use secondary indexes also here. So here the primary indexes are what? Salary. The secondary indexes are just blocks that are pointed to the file which is to be found are the records. So here the primary index is what? Salary, and the secondary index is a mechanism applied with the secondary index to find the particular index ID record and this index ID record pointed to the values of that record based on, and that values are pointed to the next record of the file. So this will be happen up to the last entry of the record will be found. And index record points to the bucket that contain pointers to all the actual record with a particular search key values. So this indexing mechanism is very important, a very emergence place in this indexing mechanism to find out the records easily, to reduce the access time of your records, to reduce the insertion of your records, to reduce the deletion of your time, deletion of your records, and to access the records, taking the reduce of the space overheaded on the record. To do this all, the indexing mechanism is an important role takes place in the DBMS. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.